Great, it's recording now. Section 3.3, differentiation rules. Today, we're going to talk about formulas for us to take derivatives efficiently so that we can go over applications. Remember, the derivative is the most important part of calculus, at least calculus 1. And we should have formulas, right? Good formulas so that we can quickly get our derivative efficiently. So, but for that, we have to start with a basic fact. We have to figure out what is the derivative of the constant function. The constant function looks like this: f of x equals c, where c is some real number, right? Some real number, positive or negative. F of x is a constant function. Let's compute in general its derivative. Remember, the derivative of a function is gotten by following this formula using limits. It is the limit as h approaches 0 of the difference quotient, right? F of x plus h minus f of x over h. But for this constant function, f of x plus h is just c, right? Because it's a constant function. The constant function pairs up any input value with a constant, in this case c, right? So this is just c, minus f of x. But f of x is also equal to c, right? Equal to c. And h on the bottom here. So now notice that c minus c is just 0, right? 0. And h on the bottom. So now h into 0, or 0 divided by h equivalently, is just h, right? It's just 0, sorry, it's just 0. Yeah, two more students joined just now. H into 0 is just 0, right? 0. So believe it or not, guys, all this comes down to 0. And the limit of a constant function is just 0, right? 0. So conclusion, the derivative of a constant function is equal to 0. So from now on, this is something that you should know very well, right? If you encounter the constant function in any form, you should know that its derivative is just 0 because there is no variation to measure, right? Remember, the derivative measures the instantaneous rate of change. There is no change. So derivative of the constant function 0. Now, how does this, is this or understood or explained graphically? Well, if you graph the constant function, right? Constant function, if you graph it, the constant function looks like a horizontal line, right? A horizontal line. Above the x-axis if the constant function is positive, below the x-axis if the constant function is negative, right? Yeah, let's do it nicely. So now, if you draw a tangent line at any point along the graph of the constant function, well, not hard to see that tangent line, if you take any arbitrary point on the constant function, will coincide, right, with the graph of the tangent function, of the constant function itself, right? Will look like a horizontal line. But we know that the graph, the slope of horizontal lines is just 0, right? It's just 0. So if you pick any input value for the constant function and you draw the tangent line will look like this red line. So the slope of the horizontal tangent line is 0, right? 0, or is equal to 0. Equal to 0. All right? So that is the idea when you look at this graphically, right? The derivative of constant function 0. Now, some notation here. We have studied this notation f prime of x equals 0, right? But turns out there is another notation. This notation is due to Isaac Newton, but this other notation was introduced by the German mathematician Leibniz. Leibniz emphasized the fact that is related to with respect to which variable you're taking the derivative. So he introduces notation, derivative d of f of x with respect to x, with respect to x. Turns out when you are dealing with functions in two variables, it is possible to take derivative with respect to x, with respect to y, with respect to time. So this notation emphasizes that, okay? But it's equivalent to this. So, but for the formula that I'm going to state, turns out this notation is better. You will see. Also, there is this other notation, capital D, y here for the function, and then x on the bottom to specify that we are taking the derivative with respect to x, right? With respect to x. Okay, so the constant rule, the first rule that we just went over, right? We proved it. Says that if you take the derivative of any constant function whatsoever, the result should be just zero, right? Zero. Where C is any real number, this C. So let's see some examples of this constant rule. Suppose you encounter, when you're taking derivative of the constant function 0 with respect to x. Well, according to my constant rule, this will be just equal to 0, right? 0. What about this guy? The derivative of the constant function 2 times pi with respect to x. What this should be equal to? Anybody could tell us in the chat or verbally? Someone wrote it in the chat.
0.
0, right? Excellent, excellent, guys. 0, right? Yeah, I see you are sharp. 0, 0. Yeah, so because, very good, math. 0 because the number is fancy, 2 times pi is a transcendental number, but bottom line, this is a constant function, so it's 0, 0, no variation. Next, derivative with respect to x, I'm using Leibniz notation, notice, of this constant function, minus 2 over 3. What should be this equal to? Anybody? You can write it on the chat or say it. What do you think? Some activity on the chat.
Also 0.
Also 0, right? Marcus, also 0, right? Yeah, it's negative, Professor. Yeah, but it's still a constant. It's a real number, right? So 0, 0, no variation. Very good, very good. And this one, derivative with respect to x of the square root of the number 3. What would be this equal to? Anybody? Very good. Yeah, I just want everybody to be crystal clear with this fact, right? Yeah, very good, Gonka, very good, Marcos. 0, right? 0, because the square root of 3 is a fancy number. It's an irrational number, right? But it's still a constant of 0. So anytime we encounter this type of derivatives, the result will be just 0. So we are not going to write anything for that, right? Because it will be 0. Great. That is the first rule. It's called the constant rule. But besides the constant rule, mathematicians came out with this so-called power rule, which is a very powerful rule between quotations, because it says that the derivative of x raised to any power, right, any power, is just n up front here, you bring it down, and times x raised to 1 less than this, n minus 1. N minus 1. What, Professor? How did I figure this out? Well, there is a formal proof for this, but I can give you an idea where or how mathematicians figure this out. Recall in previous lectures, we showed using the definition of derivative that if f of x is equal to x squared, then we found its derivative, right? Its derivative using the definition of derivative via limits, that was twice x, right? Twice x. Mathematicians, yeah, very good, ma. Yeah, that's it, right? That was it, right? So mathematicians look at this, right? They are good at catching patterns. They said, isn't x equal to x raised to 1? And isn't this guy appearing here, right? Kind of coming up front. And isn't this number 1, 2 minus 1? The idea came from that, right? Of course, they had to use a procedure called induction and show that this works for any n first n whole number. And then they went to show it, to to show that it works also if n is a rational number, the irrational, it works for any real number n. We are going to take this result completely in general, okay? So the power rule will be derivative of x to the n, and you bring it down here, put it up front, and then you keep, instead of the exponent n, one less, n minus one, okay? All right, so now, examples, derivative of x cubed with respect to x. Applying our power rule, then we can say that this number 3 should come down, right? Should come down, you bring it down. I can see some students readily writing the answer for this, right? This should come down, 3 up front. X raised to what? 1 less, 3 minus 1, right? 3 minus 1, this is how it works. And then you simplify this to 3x square, right? Final answer. Very good. And I see that the students on the chat, they wrote it out, right? Gonka, very good. Excellent, excellent. Yeah, this is a very powerful rule that you should really master. Now, we said that this power rule is powerful between quotations because it doesn't work only for whole numbers, as 3, 4, 5, 7. It also works for negative numbers, any real number. So if they ask you to take the derivative with respect to x of x raised to negative 5, then applying the power rule, this is going to be equal to this. Negative 5, as it is, comes down up front. X raised to negative 5 minus 1, 1 less, right? Be careful when you compute this. Minus 5, x raised to minus 5 minus 1 minus 6, right? Minus 6. Excellent. Yeah, that's it. But now, very good, Deep, right? Excellent, you got it. But now, notice mathematicians often don't like to see negative exponents as part of the final answer, right? You might have noticed that at this moment, right? At this point of your career. So what they do is they make some changes so that this final answer doesn't show negative exponents. They write x raised to minus 6 as 1 over x to the 6th power, right? This is what they do. And then they simplify. Excellent, excellent, Marcos. Yeah, see. Yeah, we're headed there. And then finally, this becomes simply minus 5, which mathematicians place in the middle, right? Over x to the 6. This is most likely what you will see on the multiple choices, right? Not this form, but this form, which is completely equivalent. Yeah, very good, very good. All right, next question. Take the derivative with respect to x of x raised to 2.7. Well, again, let's follow the power rule. Professor, it's a decimal. Yep, but the power rule still holds. It still holds. So still you do this. Bring it down, 2.7 times x raised to 2.7 minus 1. And that, when simplified, is just equal to this, 2.7 x raised to 2.7 minus 1, 1.7, right? 1.7. And that's it, right? That's it. Very good, very good. That's the answer. Here is another one. I see some questions on the Agonka. Yeah, very good, very good. Very good. Yeah, very good, very good. Okay, so
I'm sorry, I don't know if you can repeat the second one because I missed that.
This one, the second one, to
Yeah,
x raised to minus 5. Sure, of course. Look, we were saying that this power rule is good for whole numbers as exponent, but also for negative numbers. It's good for any real number here on the top, okay? So we follow the power rule. Power rule says bring it down, the negative 5 up front, and keep as a new exponent 1 less, minus 5 minus 1, right?
Okay.
This is here, and this, Robert, becomes this minus 5 minus 6 becomes this minus 6, right? You follow? Yeah, and then we said that mathematicians don't like to see negative exponents as part of the final answer. So what they do is they transform this, they change this as 1 over x to the 6, right?
Okay.
And then this is it, finally, this is what you will find in the multiple choices. Follow now?
Okay. Yeah, I got it. I got it now.
Yeah, great. Excellent, excellent.
Thank you.
Yeah, very good, guys. Excellent. Yeah, if for some reason you get kicked out, just come back and I will let you in, okay? Yes, okay, great. Now, derivative of the square root of x. What should we do here? Well, Professor, there is no exponent there. Well, but you know that
1 over 2.
You can 1 over 2. Yes, we can rewrite this. Good idea there. As the derivative of x raised to 1/2, right? Raised to 1/2. Very good. And now I have the form to apply my power rule. Power rule says bring this down, put it up front 1/2. And the new exponent will be 1/2 minus 1. This will be 1/2 x raised to 1. 1/2 minus 1, knowing that this number 1 is just 1 over 1, right? 1 over 1. Put 1 here below. Taking the LCD of 2 and 1, 2. This is going to be 2, 2, 1 minus 2 is minus 1, right? Minus 1 on the top, 2 on the bottom. This is what I get as my result for the derivative of the square root of x. But now, remember, mathematicians, very good, Marcos, very good. Yeah, we're headed there. Remember, mathematicians don't like to see negative exponents as part of the final answer. So what they do when they get these forms, they bring this down. So we're going to have 1/2, 1 over x raised to 1/2, right? Now, also mathematicians don't like to see fractional exponent, right? Whenever possible, they change it to radical form. So don't be surprised if you see this just as the following: 1 times 1, 1 on the top, on the bottom twice, and instead of writing x raised to 1/2, mathematicians write a square root of x. So this should be the final answer for the derivative of the square root of x, okay? And I want you to remember that because it will facilitate our computations later. So I'm writing here, from now on, the derivative of the square root of x will be equal to 1 over 2 times the square root of x, okay? All simplified, all worked out, right? So we don't have to go through this anymore. Very good. Try to keep this in mind. Write it down somewhere. Okay, great. Now, one more example here. A tricky one, but well, let's do it, right? So what is the derivative of the identity function x? Identity function with respect to x. I see students. Yeah, Marcos, very good, very good. We're headed there, right? I want to apply the power rule. So what we're going to do is I'm going to write on top of this x, this invisible one that is supposed to be the exponent, right? When you don't see exponent, it means that the number 1 is the exponent. And all that just to get the form to apply the power rule. So the power rule says, okay, now bring down your exponent, the 1, right? Down. Multiplying up front and keep here 1 less, 1 minus 1, right? 1 minus 1. But 1 minus 1 is just 0, right? So we have 1 times x raised to the 0, and x raised to the 0 is 1. 1 times 1, just 1, right? So I want you to remember, guys, that the derivative of the identity function x is just equal to 1. It's just equal to 1, right? Yeah, very good, very good. Yeah, Miguel also, excellent, excellent, guys, right? Yeah, I'm glad that you guys are aware of this. So 2 results that I want you to keep in mind: derivative of constant function 0, derivative of identity function 1, right? And if we encounter this guy, derivative of the square root of x, 1 over 2 times the square root of x, okay? Great. So from now on, derivative of x with respect to x will be just 1. We just said it there, right? Very good. So now let's talk about the constant multiple rule, and then we'll give you some exercises, okay?
Professor?
This is an, yeah, go ahead, Ma.
I'm sorry,
question?
just a question. Yes.
Sure, sure.
For when you did x 1 over 2, and then you made that into 2 square root x, I remember that it would usually be like if it's that 2 is like a small 2 on top of the square root, like not on top, but like on the corner of it. Is it a
On the-
whole number alone, or is
let's see, note, right? Note, you're talking about x raised to 1/2, right?
yeah?
Yeah, the rule is this is going to be a square root of this number here, this number 2, let's highlight it. This number should be the index. And this number should be the one on top of the variable, right? So this way,
Right,
I will
yeah.
show you. Yeah, so this will be a square root 2 here of x raised to 1. But x raised to 1 is just x, right? And when the index is 2, mathematicians don't write it. So this becomes this. Now it's better?
Right, yes.
Yeah,
Okay,
right.
okay. So
Yeah,
we can
yeah.
just, so when you wrote, but you wrote 2 next to it, so
The 2
2
next to it
under-
is because of this. This is the 2 next to it. The 2 next to it is comes from here 2 times. It was
Oh,
multiplying.
okay, I
yeah,
see.
1 times 1
see.
is
Okay.
now there. Okay, great.
Right, right. I'm sorry. Okay,
Yeah,
thank
no,
you.
it's okay. It's okay, guys. Don't hold anything back. Instead, share it right with all of us. Yeah, very good, very good. Yeah, very good. Excellent, excellent, guys. Yeah, so we're clear now. Okay, now I'm gonna show you this constant multiple rule, and then we're gonna go some exercise on the worksheet. What is the constant multiple rule? Well, it says that if you encounter a function being multiplied by some real number c, and you are taking a derivative of all that, this rule says that you should feel free to take this constant outside the derivative, this way. So the constant outside the derivative, and then you just focus on taking the derivative of the function. And the result of this gets multiplied by the constant, right? It's called the constant multiple rule. C is just some constant, some real number. Example of the constant multiple rule. Suppose they ask you to take the derivative with respect to x of 5x to the 4th power. Notice here the number 5 plays the role of the constant, right? So the constant multiple rule is telling me that I should feel free to take this number outside of the derivative, right? Outside of the derivative, and I should just focus my attention to get this derivative, the derivative of x to the 4. But thankfully, I know how to deal with this guy, right? We have the power rule. So because of the power rule, this should be 4 coming down, right? 4 within parentheses up front. And what stays? 1 less, right? 1 less, 4 minus 1. And therefore, this becomes 5 times 4 is 20. X raised to 4 minus 1, 3, right? 3. So 20 times x to the 3rd power should be the final answer, right? Final answer. Very good, guys. It's called the constant multiple rule because this is a constant multiplying a function, right? Here is another example for the constant multiple rule. Suppose they ask you to take the derivative with respect to f of 3 over x. What should you do? Well, this will be derivative with respect to x of 3 times 1 over x, right? 1 over x. Professor, why are you separating 3 from the rest? Well, I just need to have a constant that I can take outside, right? By the constant multiple rule. So that's the trick. So 3 comes out based on the constant multiple rule. And this guy, 1 over x, I'm going to write it as x raised to -1. Why are you doing that, Professor? Well, because I want this form so I can apply the power rule, right? The power rule. So finally, this will become the following: 3 times derivative of x raised to -1 using the power rule should be -1 comes up front, x raised to -1, one less, right? But this is going to be equal to what? -3. 3 times -1, and this x raised to -1 minus 1, -2, right? -2. That should be the answer. But remember, mathematicians don't like to see negative exponents as part of the final answer. So this has to be written as 1 over x squared. 1 over x squared. Negative 3 times 1 is negative 3. X squared here, right? That's it. This should be the final answer, the one that you should find among the choices, right? You follow, guys? It's another application of the constant multiple rule. Here, one more, and then we'll go over exercises. Another application of the constant multiple rule. Suppose they ask you to take the derivative of these expressions 4 over 5 times t raised to 15 with respect to t, bear with you, right? Okay, quickly, I noticed that this guy is just a constant, right? This guy, 4/5, right? According to the constant multiple rule, I can take this outside of the derivative and I can focus my attention on taking the derivative of this t raised to 15, right? Constant out. But that, I see some students already figure this out, will be 4/5. Remember this guy, the exponent comes up front, right, as 15. And this stays with 15 minus 1, right? Minus 1. Very good, very good. And this should be equal to, yeah, very good, Marcos. Yeah, we're headed there. We're going to get there. Look, 15 times 4 is 60. 5 into 60 is 12, right? Or equivalently, 5 into 15, 3. 3 times 4 is 12. Any way you do it, you should get 12 here. T raised to 14, right? 14. This should be the final answer. Very good, guys. Yeah, very good, very good. So now I think it's time for you guys to practice. Remember, practice makes the master. So let's practice, okay? I'm gonna give you 3 exercises here. The first one is this, very straightforward. They say, what is the derivative of this function? Y equal 12. What is its derivative? Could you figure this out? Hint, remember the constant rule, right? Constant rule. Yeah, you can write it in the chat. Or you can say it. Yeah, do this. I see 4 answers quickly. Very good, very good. Yeah, Deep, Gonka, Marcos. Excellent, right? It's a constant function, never changes. So its derivative should be 0. Miguel, also very good, right? Derivative immediately 0, right? 0. And let's use this notation. Y prime, 0, right? Derivative. That's it. Here is another one with this other notation, right? Find dy dx, derivative of y with respect to x, right? Of this function. Now the function is y equal minus 6x to the 5th. Can you figure out the derivative of this guy? Yeah, this is a function. Find the derivative of y with respect to x. What would be that? This is a function, right? Yeah, very good. Yeah, so, I see students posting answers. Yeah, Marcos, yeah, you got it. Miguel, Gonka, Deep. Excellent, guys. Excellent. I see you guys are sharp. Also, yep. Yeah, very good, guys. So remember, the constant comes out, right? Because of the constant multiple rule. And then we focus our attention to the derivative of x to the 5th power, right? The constant out. We take the derivative. But this guy, according to the power rule, is going to be phi coming down up front, x raised to 5 minus 1, right? Simplifying, negative 6 times 5 is negative 30, right? And x raised to 5 minus 1, 4, right? And that is this guy. Excellent, great. One more here, and then we will move on. Can you try this? the function is y equal x to the 14. Find the derivative of y with respect to x, right? Or y prime is the same. Very good, guys. Very good, Gonka. Very good. Deep, Miguel. Excellent, guys. Very good. Direct application of the power rule, right? The power rule says, if you get a power function, just bring this down, put it up front, 14, and what it stays as the new exponent is one less. So 14x to a 13, right? 13, yeah, very good. So telling us that the answer is this. Very good. Now we have to take the derivative of this polynomial function, right? So let me give you more examples. Let me give you an additional rule that is going to allow us to take the derivative of these polynomial functions, which is ultimately the goal, because we're going to work with these polynomial functions a lot. So let's go back here to our notes and talk about the sum and difference rules. Okay, sum and difference rules. Turns out these derivatives, they behave very nicely over sums and also over differences of functions. Okay, why you say that, Professor? They behave very nice over sums, over differences, in the following sense. When you take the derivative of the sum of two functions or the derivative of the difference of two functions, turns out you can distribute your derivative over the sum or over the difference this way. So the derivative of the sum of two functions will be the sum of the derivative of the two functions. Okay, as you can see there, the derivative of the difference of two functions will be the difference of the derivative of the function, right? Yeah, so feel free to distribute your derivative over sums over differences. Now, if this notation is too much for you to remember, equivalently, we can use Newton's notation and say the derivative of f plus g is just f prime plus g prime, right? And the same for the difference. The derivative of the difference of f minus g is f prime minus g prime. You see, you should feel free to distribute the derivative over sums over differences, okay? Now, having said that, let me give you this example that will show you how to take the derivative of a polynomial function. Examples here. Example number 1 says, take the derivative of x cubed minus 4x plus 7. It's a polynomial function of degree 3. Okay, so since I know that derivatives are friends of sums, differences, right, in the sense that you can distribute the derivative over, we're going to just distribute this derivative over this difference over this sum, right, directly. So we're gonna get here derivative with respect to x of x cubed minus derivative with respect to x of 4 times x plus derivative with respect to x of the constant function 7. Good. Now, the derivative of this guy using the power rule, right? The power rule will be 3 coming down front, right? Times x raised to 1 less, right? 3 minus 1. Minus, and I can see that some students are already getting this, right? Yeah, very good, man. Yeah, 3x squared is going to be, right? Yeah, soon I will stop putting this minus 1. We will compute it directly, right? Yeah, minus derivative of this. This part, I see that there is a constant multiplying the identity function x. So I can say that this will be 4 times derivative of the identity function x with respect to x plus this. Anyone could tell me what is the derivative of this constant function 7 with respect to x? Very good, guys. Ma, Goka, very good. Zero, right? Zero. Remember, when we encounter this situation, we're gonna just either sometimes even ignore it, they say nothing, zero, or you can write zero there for now. Right? Yeah, good. Simplifying, this will become 3 times x raised to the second power minus 4 derivative of x with respect to x. What is this derivative? Anybody could tell me? Derivative of x with respect to x, derivative of the identity function. Very good, guys. Gonka, very good. Marcos, very good. Yeah, I see you guys are sharp. This is just one, right? This is what the identity function. Remember, we explained that derivative of the x with respect to x is just one, always. All right, so then simplifying, finally, this will be 3x squared minus 4, right? Minus 4. That should be our final answer. Great. Here is another example. It says take the derivative with respect to x of yeah, very good. Yeah, we got it. Of this function that looks like a polynomial function, but it's not really a polynomial function because of this term. Look, this term has a negative exponent, so it's not a polynomial, but the idea is to show you how you can apply this technique that we applied before, even when terms of the function look like this. I will show you. So if they ask you to take the derivative of a function that look like this, first step, before taking your derivative, rewrite this 2 over x to the second power as this. I will show you. Rewrite it as derivative with respect to x of minus, look, this is division by 2. I'm going to write it as multiplication by 1/2 this way. Minus 1/2 times x to the 4 plus 3 x to the third minus, here, look, put it up here, x raised to minus 2. Professor, why are you doing that? Well, because I want to make this function look like a polynomial, right? It's not a polynomial function, but I want it to look like a polynomial function so that I can apply easily my power rule together with the other rules, right? Together with the other rules. So it's a good policy to turn this into this before taking the derivative, okay? All right, so now after you do that, since we know that derivatives are friends of sums, friends of differences, let's just distribute, right, the derivative. You can always do that. So this will become the derivative with respect to x of this function minus 1/2 times x to the 4 plus derivative with respect to x of 3 times x to the third minus derivative with respect to x of 2 times x raised to minus 2, right? And I see some writing on the chat. Marcos, yeah, we're headed there. Very good. Yeah, very good. So then notice this is a constant. So we know we have this constant product rule, right? So, or constant multiple rules is the name of the property, right? Constant multiple rule says that we can take out side of the derivative over constant and focus on taking the derivative of the function, right? So this becomes this plus this number 3 is also a constant. Based on the constant multiple rule, this becomes this. Notice I'm doing this step by step, guys, but eventually we will do it quickly, right? We will do it quickly. So another constant that I can take out, 2 derivative with respect to x of x raised to minus 2. Very good. Now, time to deal with this part, derivative of x to the 4. The derivative of x to the 4 using the power rule will be this guy 4 comes down up front, and what stays here is 1 less, right? 4 minus 1. Probably this will be the last time I will put this minus 1. We will do it directly next time. 3 times, applying the power rule again, this 3 comes up front, and what is left is x raised to 3 minus 1 minus, here the same, right? Minus 2. Be careful with the sign here, guys. The exponent comes down as it is minus 2. And what stays here is -2 minus 1, right? -2 minus 1. Great. Yeah, so far so good. So now let's just work this out. -1/2 times 4, minus times plus minus, 1/2 times 4, 2 into 4 is 2, x raised to 4 minus 1, 3, plus 3 times 3, 9, x raised to 3 minus 1 is 2, minus and minus, we multiply plus 4, x raised to -2 minus 1, -3, right? -3. Very good. Now, this should be the answer except for this. Look, this guy has a negative exponent, right? This and this guy are okay, but this one has a negative exponent. So remember, mathematicians don't like to see negative exponents as part of final answers. So what you should do if you get this form is to change this for 1 over x to the third, right? They are equivalent, but the exponent here is positive. And then just rewrite this as -2x to the third plus 9x squared. The number 4 multiplying 1 is 4. And here x to the third, right? X to the third. These guys, believe it or not, should be the answer, right? Should be the answer. Very good, very good. Yeah. Very good, excellent. Yep, very good. Now, time for you to practice, right? Before we go into the product rule and the quotient rule, time for us to practice. Let's practice as much as we can, guys. This is a very important tool for you taking derivative of these polynomial functions. All right, so let's start with this. Can you try this one? Number 5. Can you find the derivative of this function? I will make it bigger so I can see. Yeah, find the derivative, find y prime, right? The derivative of this function, y equal x to the 8 minus 6x to the 7 minus 8x to the 6 plus x. Can you find the derivative of y with respect to x or y prime? Try guys. Again, distribute your derivative over and then the sums over the differences, and then apply your rules, right? The power rule, the constant multiple rule, and the fact that the derivative of the identity function is just 1. The derivative of the constant function is 0, right? So yeah, do number 5. Yeah, I see 2 students posting answers. Yeah, it's not that difficult, and you really should master this. This is going to be a tool that is going to help us a lot for our application. So very good, very good. Excellent, excellent. Yeah, very good, Gonka, very good, Robert. Marcus also, right? Excellent. Yep, in order to take the derivative, just distribute the derivative over. Yeah, Miguel, that's good. That's great. Yeah, you got it. Yeah, so we have to take the derivative of this derivative with respect to x of x to the 8 minus derivative with respect to x of 6x raised to 7 minus derivative with respect to x of 8x to the 6 plus derivative with respect to x of the identity function x, right? But now, thankfully, we know how to get this derivative using the power rule, right? A comes down up front, and here we keep 1 less. 8 minus 1, 7, right? That this time I did it directly. Ax raised to 7 is the derivative of the first term, minus derivative of the second term. Once you bring this outside, 6, right, out, you have to focus on taking the derivative with respect to x of this x to the 7, right? We will do it next. Let's leave it there. Minus. Same idea here. 8 is just a constant. So based on the constant multiple rule outside, and then you focus on taking the derivative of x to the 6. Plus, anyone could tell me what's the derivative of the identity function x? In the chat or verbally? Yeah, I'm glad, guys, that you are aware, right? Excellent, excellent. Marcos, Ma, Deep, Miguel, 1, right? 1. Yeah, don't be surprised on the homework. Don't be surprised on the exam. This is just 1. All right, then finally, yeah, you can say, okay, 8x to the 7 minus 6. This 7 comes down, right? And what stays there is 7 minus 1, which is going to be the number 6, right? Number 6 there. Minus 8. Derivative of x to the 6, remember, by the power rule, 6 comes down up front, and what stays as exponent is 1 less than 6, 5. Plus this number 1, the derivative of the identity function, right? And finally, just putting everything together, this should be 8x to the 7 minus 6 times 7, 42, x to the 6 power, minus 8 times 6, 48, x to the 5th power, plus 1. And when you look through, go term by term, right? What you get is this guy, right? X to the 8, x to the 7, minus 42, x to the 6, minus 48, x to the 5th, plus 1. Be careful when you choose your answer, guys, on the homework, on the exams, right? They're very close to each other, the choices. So go term by term, sign by sign, make sure that this is the one that you are choosing, right? Very good, excellent. Now let's go over some questions that are a little bit tricky. This one, I think it's another one, direct application, and we're gonna do it quicker this time. Can you try this? Number 6. Hint, use the constant multiple rule together with a power rule, right? Together with a power rule. There is some simplifications needed on the way, but they're not that difficult. So, very good, Deep, very good. Conca, Marcos, yeah, very good, guys, very good. Yeah, so I see you guys are sharp. Look, derivative is going to be the derivative of this first term. There's a constant 1/2 that comes outside, right? And then times what? The number 10 comes down, right? 10. And the new exponent is 1 less, 9, right? 9. Minus, minus, because you can distribute derivatives over differences. Now the constant 1/3 outside the derivative of x cubed, using the power rule is this. 3 comes down, x raised to 1 less, second power, right? And the rest is just simplification here. So if you simplify this derivative, 1/2 of 10 is just 5, x to the 9 minus 1/3 of 3, 3 into 3, 1, just 1. You don't have to write 1 there, so it's just minus x squared, right? Yeah, excellent, excellent. So telling us that this is the answer. Very good. Very good, guys. This derivative also should be easy to find. So let's look for, you can do it at home, this one too. Let's look for other forms. Then we can now explore what's going to happen if we now are asked to find the equation of a tangent line or the slope of a tangent line, right? Let's go gradually. Let's start here. What if they ask you to find the slope of the curve at the point indicated? And this is a problem that we have done before, right? But we were using the definition of the limit, the derivative, sorry, via limits, right? It was very tedious. But now that we have formulas, it shouldn't be that long, right? Basically, they're asking you to figure out for this function y equal x squared, whose graph is this parabola, right? At x equals 6, what is the slope of the tangent line, right? The slope of this line at x equals 6. But that is just the derivative, right? The derivative evaluated at 6, right? But now the good news is that we have a way to compute the derivative, right? Derivative of y equal x squared applying the power rule is 2 comes down, x stays with 1 less here, 2 minus 1 is just 1, y prime is 2x, right? And at x equals 6, your derivative evaluated at 6 will be just twice 6, right? Which is going to be just 12. Very good. So this is how you do this type of problems, right? Can you try number 10 in this one? Can you try that using your formulas, right? Try this. Find the slope of the curve at x equal 3, right? At x equal 3. You don't need to graph this. This is just for me to explain what this problem is all about, right? They're just trying to figure out the slope of the tangent line when they say the slope of the curve. Yeah, the hint is find the derivative first, right? Hint, find first y prime, the derivative, right? Using your formulas, right? The formulas that you know, and then evaluate that derivative at x equal 3. I see some activity on the chat room, which is good. Yeah, Marcus, Deep. Very good, guys. Very good. Very good. Yeah, very good. Very good. Excellent. Great. Very good, guys. Very good. So if you want the slope of a curve, it's the slope of the tangent line. So you must take the derivative, right? But this time we know how to take derivatives quickly. We have formulas. The derivative of this part will be derivative of 4x squared first. Derivative of 4x squared. 4 is a constant, so comes outside of the derivative. And then you have to multiply that by the derivative of x squared, right? Derivative of x squared. But the derivative of x squared is 2 comes down. X stays with 1 less. 2 minus 1 is 1. I don't have to write this one, right? Minus. Derivative of this part should be 9 is a constant, right? Multiplied by the derivative of x. But the derivative of x is just 1, right? Derivative of x is just 1. So this is the derivative. Y prime is equal to 8x minus 9. That is the derivative, right? Now, at x equal 3, then my derivative evaluated at 3 should be 8 times 3 minus 9, right? 8 times 3 minus 9. But what is 8 times 3 minus 9? 8 times 3 is 24 minus 9. That is just 15, right? 15. Now, guys, if you encounter this situation and the numbers are not friendly, feel free to use your scientific calculator, right? Use your scientific calculator, or if you're not sure about your computation, you put it in your calculator. You can always check with 15, right? Very good. So therefore, the answer should be this guy, right? Excellent. Excellent. Now, there is a tricky one here, number 11. Try to do this, but I'm going to give you a hint, okay? The function is y equal twice square root of x. It's dealing with some multiple of this square root function, right? And for the hint, recall, I gave you a formula to compute the derivative of this function, right? The function square root of x has as its derivative 1 over twice square root of x, right? In simplified form, right? Use this, and then together with the constant multiple rule, right? To compute the derivative, right? Yeah, fine, y prime. Once you get your derivative, then you just substitute x equal 49 into your derivative. That's gonna give you the slope of the tangent line, what they want here, right? Yeah, try guys. And then we will move to other cases. I see some activity in the chat room. Let's check. Marcos, yeah, you made my day. Very good, you got it. Very good, excellent, right? Yeah, very important, this formula. Write it down somewhere and have it handy, because you're gonna use this on your homework, and also when you take your exam, make sure this formula is somewhere there. All simplified. Yeah, very good, guys. So we are supposed to take the derivative first, right? But the derivative of this guy is going to be the derivative. Let's write it, right? So everybody can see what we're going to do clearly. Is this derivative, right? Using Leibniz notation. But we have this nice property, the constant multiple rule, that says that constants can be taken outside of the derivative, and we can just focus on taking the derivative of the function square root of x, which we know very well, right? Which is this. So this is going to become twice this guy. This is this, right? So believe it or not, guys, this in simplified form, after you cancel these two on the top, two on the bottom, is just 1 over the square root of x. For this particular problem, the derivative is this, the formula for the slope of the tangent line, 1 over square root of x, right? That's this. Now, for x equal 49, right? Then y prime, evaluate the 49, the slope of the tangent line at x equal 49 will be 1 over, we substitute x with 49, right? Yeah, this way. The square root of 49 is just 7, right? 7. So 1 over 7 should be the slope of the tangent line, right? 1 over 7, which is this guy, right? Follow, guys? Very good. This here is another one where they are asking you to figure out not just the slope of the tangent line, but the equation of the tangent line, right? So I'm gonna do number 14. I'm gonna ask you to number 15, okay? For number 14, they are giving you this function y equal x squared plus 3, right? And they are asking you to figure out what is the equation of the tangent line at this given point. So first, you compute your derivative, because we know that the derivative will give us a formula for the slope of the tangent line. But now, fortunately, we have formulas now for derivative, right? Derivative of x squared is just twice x. Derivative of 3, nothing, 0, right? 0. So I'm not going to write it. So this is my derivative. Now, at x equal 4, why, Professor, at x equal 4? Because of this, right? First coordinate at x equal 4. Then substituting my derivative formula at x equal 4, I will get the slope of the tangent line at the input value x equal 4, which happens to be 2 times 4, 8, right? 8. So with the slope 8 and point 4, 19, I can find easily the equation of the line, right? Having a slope 8 and passing to this point. I'm going to use this so-called point slope form with x1 y1 19, right? So if you do that, y1 is 19, slope 8 times x minus x14, y minus 19 equal 8x minus 32. And adding 19 to both sides, then we should get our answer, right? Y equal 8x minus, if the numbers are not friendly, guys, always use your calculator. Minus 32 plus 19 is just minus 13, right? Minus 13, so minus 13 here. So, which is telling me that the answer should be this guy, right? Yeah, very good. Can you try number 15? And then we will move on. Try that, please. And then we will move on. And try to remember all these, guys, when you go over your homework. New homework is going to appear today related to this part, okay? And of course, product rule, quotient rule that we're going to do next, right? Try to do this. Yeah, if you don't see well, the function is this, y equal x squared minus x. And the hint is to quickly find the derivative first, right? With the derivative, you can get the slope of the tangent line. And with that, you can get the equation of the tangent line, right? Let's see for number 15. Deep, you're close, but I think you need to adjust it a little bit. It's very close to what it should be, but you need to adjust it. Be careful with the signs there. Yeah, now, good. Deep, good. Very good, very good. Yeah, very good, guys. Don't feel bad if you don't get it at the first try, because it's what basically happens in mathematics. You have to try until eventually you get the right. Gonka, very good, very excellent. Yeah, very good. Yeah, very good, guys. So first step, in order to have the slope of the tangent line, we must take the derivative, right? But the derivative is derivative of x squared twice x, right? Minus derivative of x, derivative of identity function is just 1, right? So this is the derivative of the function. This is a formula for me to compute the slope of the tangent line. So at x equal minus 4, which is the input value, right? Minus 4. I see more students figure this out. Minus 4. Then I can say that y prime evaluated at minus 4 is equal to this twice minus 4 minus 1, right? Minus 1. Y prime at minus 4 is equal to, yeah, Miguel, very good also. Very good, excellent, we're headed there. So 2 times minus 4 minus 8 minus 1. So the derivative evaluated at negative 4 is minus 8 minus 1 minus 9. That is the slope, right? Slope of our tangent line, minus 9. This slope together with this point, minus 4, 20, should be used to find the equation of our tangent line, which in point slope form is this, right? Point slope form, where x1 is the first coordinate, y1 the second coordinate. All right, substituting our values, we will get y minus 20, the slope negative 9, x minus x1, which is minus 4. Work this out carefully, guys, so you don't make mistakes. So minus 9x, minus a minus is plus 4, right? Plus 4, but plus 4, right? Plus 4 times negative 9, negative 36, right? Negative 36, adding 20 to both sides, finally gives me y equal negative 9x minus 16, right? Minus 16. And that is this guy, right? Excellent, excellent, guys. Excellent. Very good, very good. That's for number 15. All right. Similarly, you can work out these other examples, right? This, and you may say, Professor, here they're giving just the first coordinate. What should be the second coordinate? Yeah, maybe I should do this too and then move to, yeah, let me show you, right? Yeah, what if they don't give you the second coordinate? Yeah, let's do that. And they ask you, right, figure out the equation of the tangent line at a equal minus 3. Well, still you get the derivative, right? Which is going to be, notice 1/4 is a constant. This number 2 comes up front, and what stays here is 1 less, it's just 1, right? So this is going to be y prime 2/4 times x, simplifying y prime 1/2 of x, right? 1/2 of x. This is the derivative. I see students. Yeah, yeah, very good, Marcus. Yeah, that's what we're gonna do, right? To find the partner of this guy. Yeah, the derivative is this. So then we say at x equal minus 3, right? At this input value, they want to find the slope. This will be 1/2 of this negative 3, right? But negative 3 times 1 is negative 3 divided by 2, that is negative 1.5, right? 1.5. That's the slope. Now, for the point, we have the first coordinate, right? Negative 3, but we don't have the second coordinate, but that shouldn't be a problem because we have the function. Substituting negative 3 into the function, plugging negative 3 into the formula for the function, we get this, right? And there you have your second coordinate, right? Let's right here closer. So it shouldn't be a problem, really, guys. So now, a slope equal minus 1.5. The point is negative 3, comma. Let's compute this in our calculator, right? Negative 3 is squared divided by 4 is just 2.25, right? 2.25. And use your point slope form, which is this, with x1 negative 3 and y1 2.25, right? 2.25. Very good. So y minus 2.25 equal slope negative 1.5 times x minus x1 negative 3. Work this out carefully. Negative 1.5x. This negative times negative positive 3. But this positive 3 multiplied by this guy minus 4.5, right? Minus 4.5. Yeah, great. You can check that in your calculator. Finally, adding 2.25 to each side of this equation, you finally get y equal, canceling these two, right? Negative 1.5x. Let's see, what is this? 4.5 negative minus or plus, sorry, plus 2.25. Negative 2.25. Negative 2.25, which tells me that the answer should be just this, right? Therefore, 16, this guy. Very good, right? So in case the second coordinate is not given, by plugging the first coordinate into, you get it, and you just follow the same method. Okay, guys, so now let's talk about this one. You can do it at home, similar, right? They're all similar. But now let's talk about the product rule and the quotient rule, okay? Remember I said derivatives are friends of sums, difference in the sense that you can distribute over a sum, distribute over a difference with derivative, right? But turns out they are not so nice when it comes to products and quotients. You cannot distribute your derivative or a product this way. You cannot. Turns out the derivative of a product of two functions has a formula, which mathematicians call the product rule. Okay, and it goes like this: derivative with respect to x of f of x times g of x is equal to derivative of f of x with respect to x times g of x plus derivative of g of x with respect to x times f of x. Now, if this in Leibniz notation is too much for you to remember, try the following. Derivative of f times g in Newton's notation is equal to derivative of f times g plus derivative of g times f. Okay, so basically the derivative of the first function times the second function going from left to right, right? And then the derivative of the second function times the first function. It's a symmetric formula. As long as you take the derivative of one function, multiply by the other as it is, and add it to the derivative of the other times the other function as it is, you will get the answer. Now, how this product rule works. Example. Suppose they give you this function, h of x equal x squared plus 3 times 5x squared minus 2. And they ask you to compute this derivative. Let's use our product rule, okay? Let's use our product rule. So solution here, solution. Notice h of x is a product or a multiplication of two functions, right? So we can label one of the factors as f, say this would be f for us, and the other as g, right? And we're gonna apply our product rule. Now, the derivative of the function h then should be equal to, start with the derivative of this guy, the derivative of f. What is the derivative of f? Well, derivative of x squared is twice x, right? Derivative of 3 constant part 0, right? 0. So this is the derivative of f, right? This part. That must be multiplied by g as it is, no derivative. So this, right? Plus. Now, derivative of g, derivative of this guy. Remember, 5 is a constant, comes out, 2 comes down, multiplying 5 is a 10, right? 10. X stays with 1 less, 2 minus 1, 1, right? Stays that. Derivative of 2, 0, right? Nothing. That's the derivative of g, right? Times f as it is, this guy, x squared plus 3, right? There we go. Almost done there. Now, simply distribute the multiplication of this using the distributive property, and that should give us the answer, right? 2x times 5x squared is 2 times 5, 10. X raised to the first power multiplied by x raised to the second power. Remember, you add the exponent, 1 plus 2, 3, so x cubed here, right? X cubed. This times this guy now will be minus 2 times 2, 4x, right? Done with this part. Now for this other part, 10x times x squared is going to be 10x. Remember again, this has an invisible one as exponent, so x times x squared, x cubed, right? X cubed, 10x cubed, plus 10x times 3, 30x, right? 30x. And pretty much we should be done after combining like terms. Combining like terms, notice this term with this term are like terms, same variable part. 10x cubed plus 10x cubed is just 20x cubed, right? Add the coefficients, keep the variable part the same. And this guy with this guy also like terms, minus 4x plus 30x, minus 4 plus 30 plus 26x, right? X. So this together give me this combine. So after you combine it like that, then you're done. That's it. This is the answer. Applying the product rule, right? Yeah, and then sometimes when I do this, some students ask me, right, Professor, what if I just expand this, FOIL this out, and then take the derivative? It can be done that way too, but the thing is that later on, when we use the chain rule for our derivatives, these guys will come with exponents. This thing will be raised to the 5th power, this thing will be raised to the 3rd power, so there's no way to expand this easily. So the idea is to apply the product rule, right? To apply the product rule. Very good. Yeah, so I want you to practice on the product rule once and for all. Why don't we start with this one, number 2? Can you try? Yeah, let's start with numbers. Y equal 1 minus 3x squared. Go ahead. Go
Can
ahead.
you make it
Ma.
a little bigger, Professor?
Sure. Bigger. This is okay. Now you see it. Right. So the question is find y prime, the derivative of this product of two functions. And the hint is going to be make the first function your function f, make the second function, the second factor, the function g. And here is the product rule. Product rule. Yeah, try to memorize this because we're going to use this rule so much. Is this derivative of the first factor times the other factor plus derivative of the second factor times the first factor as it is, right? Yeah, this is the product rule. So try to do that and then just expand. If you need a calculator, use it because I see that the numbers are not that friendly for combining like terms, perhaps, right? Yeah, go ahead. Feel free to use it. I see. Some students have posted answers for number 2. Coca, yeah, very good. You made my day. Excellent. Very good, excellent. You got it. You're very good. Yeah, it has some, you have to go through some algebra, but in the end, it shouldn't be that difficult. So let's do it together, okay? So we are saying that this is our function f, and this is going to be our function g. We're going to apply this product rule, which says the derivative of this product of two functions should be derivative of the first factor, derivative of this part. Derivative of the constant function 1, 0. Derivative of this part, constant -3, -3, right? Let's write it like this. Out, and then derivative of this x squared, which is 2 times x, right? One less stays here, is just 1. This is the derivative of the first factor, right? Derivative of this, times the other function, the other factor as it is, the function g, 3x squared minus 36, right? This is this part. Plus derivative of g now, derivative of this function now. 3 constant, 2 comes down, x, right? Raised to 1 less, 1. Derivative of this 0. So this is the derivative times the function f as it is, this guy, right? Yeah, this guy, 3x squared. And here comes the algebra, right? The algebraic part. So y prime will be, let's simplify first, minus 6x times 3x squared minus 36 plus 6x again here, 1 minus 3x squared. Let's do the math here. This times this should be minus 18x times x squared x cubed, right? This times this should be negative and negative plus 6 times 36. Let's see in our calculator, what is that? 6 times 36. I get 216, right? 216. Don't forget the x. 6x times 1, 6x. 6x times negative 3x squared. 6 times 3, 18, negative. X times x squared, x cubed, right? X cubed. Finally, combining like terms. Notice this and these guys are they are like terms, same variable part. Combining them, y prime will be equal to minus 18 minus 36, right? Minus 36 x cubed. Remember the variable parts, they're the same. And these two combined, these are like terms as well. 222, right? You can get it in the calculator if you cannot do it mentally, it's okay. But bottom line, this should be the answer. And this is a match with this guy, right? Yeah, very good. Yeah, excellent, guys. This one also using the product rule can be done, right? Follow it, do it at home. This one too. I'm going to talk about now the quotient rule, right? To be able to get the derivative of this type of functions. And if time allows, we may go back to this. All right, or this type of thing, right? Quotient rule, what's that? Well, turns out derivatives do not behave nicely over quotients neither. You cannot distribute your derivative over a quotient. Instead, there is a formula to take derivatives of the quotient of two functions. Mathematicians have figured it out. It's called the quotient rule. It goes like this. Derivative of f of x over g of x equal to derivative of the numerator first times the denominator minus the derivative of the denominator times the numerator as it is, no derivative. And all this divided by the square of the denominator, the function of the denominator, right? G of x squared, okay? If this is too much for you to memorize, try to memorize the formula in Newton's notation, which goes like this. So right here, equivalently, f over g prime, the derivative of the quotient of two functions, is just equal to the following. Start with the derivative of f, as we did before, with the product rule, right? Then multiply by the other function as it is. On the product rule, this is plus, right? On the quotient rule is minus. Then derivative of g times the other function as it is f, right? Great. And then all over the function g on the denominator is squared like this. I think this is easier to remember, right? All right, so now let me show you an example of how you should apply your quotient rule. Suppose they ask you to find the derivative of this quotient of two functions 5x squared over 4x plus 3, function h of x. All right, so, well, you say, okay, I'm going to label the numerator as my function f and the denominator as my function g, right? G, right? So then you say, okay, the quotient rule says, right? F over g prime equal f prime g minus g prime f over g squared, right? So let's use that then. So the derivative of the function h should be, start with the derivative of the function on the top, this guy. What is the derivative of this guy? Well, 2 comes down, multiplies this 5. We can do it, you know, this way, right? On the side, perhaps. Derivative with respect to x of this guy, 5x squared. Well, it's just 5 times the derivative of x squared, right? With respect to x. But this is just twice x, right? So finally, this is just 10x. This is the derivative of this guy. 10x is what you write here, 10x. That's f prime. Times g, the function g is this. So within parentheses, you write 4x plus 3. Minus. Derivative of g now, derivative of this function. What should be that? Well, the derivative with respect to x of 4x plus 3 is just going to be the derivative of this guy. 4 comes out, derivative of x is just 1, right? Plus the derivative of the constant function 3, which is 0. So the derivative of this guy is just 4, right? That comes here within parentheses 4 times the derivative, not the derivative, the function f as it is, the function f as it is, which is this, 5x squared. All that divided by the function g squared. So 4x plus 3 is squared. And here, guys, an important hint. I'm going to write this as a note. Keep denominator in factor form. Do not expand. Keep this guy as it is. Okay? Keep the denominator in factor form. This guy on the numerator, work it out. This is the one that you work out. Okay? Note here, work this out. Simplify this, right? This stays in factor form. The numerator is the one that we're going to work out. Okay, so h prime of x will become 10x times 4x. 10 times 4 is 40. X times x, x squared, right? 10x times 3. 10 times 3 is 30. Times x, right? Forget the x. Minus here, 4 times 5, 20 x squared, right? 20x squared. On the denominator, remember, we keep our denominator as it is in factor form, right? As this is square. Very close to the final answer. Now notice these two guys are like terms, right? 40x squared and 20x squared, right? So maybe we can highlight this same variable part. So we combine them. 40x to the second power minus 20x to the second power is just 20x x to the second power plus 30x, right? 30x, that is by itself there. So now the denominator, remember, keep it in factor form. So this is the way you should present your final answer, okay? Final answer is that. This is how mathematicians will post it among the multiple choices, right? Yeah, very good. It's called the quotient rule again, and it's just the application of this formula, right? You need to memorize quotient rule and product rule because we're gonna use it a lot. All right, so now I want you to practice. Try to practice here. Let's go back to the worksheet. Can you try this one first, number 6? I'll make it bigger. Let's try this. Hint, use quotient rule. Which says f over g, the derivative of this quotient is equal to f prime g minus g prime f all over g squared. Your function is this x over 6x minus 4. Call this guy your f function, the identity function, and call this guy your g function, 6x minus 4, okay? So go ahead and try and see what we get. And remember the note, right? The denominator, leave it as a square, right? Notice in all the choices, well, almost all the choices, right? It's the square of the denominator, right? They do not expand it. It's like an agreement. Just leave it alone. The numerator is the one that you have to kind of simplify. I see. For number 6. Marcos, yeah, you made my day. Excellent, excellent. Very good, very good. Yeah, try, guys, try. Yeah, I know a lot of algebra is needed, but it's not that bad. And the more you practice on these forms, the easier it will become. Okay, so let's go over this together so we can go over more forms. If this is our function, then y prime, our derivative, right, should be equal to the following using the quotient rule. Quotient rule says take the derivative of the function on the top first, derivative of f. The derivative of this identity function is just the number 1, right? 1. So 1 times the function g, which is this. I'm going to write it within parentheses, 6x minus 4. This is this part. Minus derivative of g now, derivative of this guy. Remember, it's going to be derivative of 6x. Constant 6 comes out, derivative of x is 1. So that's going to be just 6, right? Derivative of 4, 0. 6. Multiply by f. F is this function as it is, 5 times x. And all that divided by the square of the function g, which is this, right? 6x minus 4 is squared. Remember, keep this denominator in factor form, in exponential form, if you want to call this form. Exponential form, keep it as it is. The one that we have to simplify is the top, right? The top. Work this out. So y prime will be equal to what? Keep the denominator as 6x minus 4 squared. The numerator will be 1 times this 6x 1 times negative 4 minus 4 minus 6x. Notice 6x minus 6x will be just 0, right? These two guys, they cancel. And I am left with negative 4 on the top, negative 4 on the top, over 6x minus 4 is squared, right? Squared. Look through the choices. Remember, mathematicians like to place the negative sign in the middle. So not a surprise if on the choices you will find this. It's the same as what we got. So therefore, the answer should be this one, right? Follow, guys? This. Very good. Can you try number 7 now? This one. Hint again, use quotient rule, right? Quotient rule. And what is the quotient rule? Is this: f over g prime is equal to f prime g minus g prime f over g squared. I always prefer to take the derivatives first, right? In our textbook, the order of these two factors might be switched, but it's the same formula, okay? So either follow my way or the way it's done in the textbook. There are different forms for the quotient rule, but they are all equivalent. So just follow one, right? The one you feel more comfortable with. Yeah, call this is your function x minus 3 over x plus 3, right? Call this function your function f on the top, and this one call this your function g, x plus 3, right? And use the quotient rule, right, to solve this. And remember, the denominator, it's an agreement, right? Should not be expanded. You just keep it in power form or factor form, right? Let's see, check. Ma, let me check, okay? You got it. Yeah, excellent, excellent. Yeah, you made my day. Excellent, excellent, guys, that you're trying. You don't have to be right all the time, right? But trying is good, because then after you do it several times, it becomes easier, it becomes like natural to do. Excellent, excellent. Very good, very good. Yeah, it's called the quotient rule, and you should memorize these two rules, right? The product rule and the quotient rule, because on the future lectures, we will use them a lot. Okay, guys, so let's try to do it together. Nice, slowly, so everybody can follow, okay? More students are have figured out the answer. Marcos, yeah, very good. Marcos is suggesting the use of flashcards. Yeah, anything that helps you guys to, you know, go through this course, any strategies are welcome, okay? Just follow them. Very good. So we have to start by taking the derivative of f. But what's the derivative of f? It's the derivative of this guy, right? I'm gonna do it on the side, because sometimes students ask me, Professor, where this derivative come from? Well, this is this. Derivative of this guy is going to be derivative of x minus derivative of 3, the constant function, right? But the derivative of x is just 1. The derivative of 3 is 0, disappears. So believe it or not, guys, the derivative of x minus 3 is just the number 1. Goes here. Times the function g, right? Following the product rule, the quotient rule, sorry. The function g is x plus 3 here, as it is, right? without derivative. Minus the derivative of g now, the derivative of this. Following the same reasoning here, the derivative of this guy, once you distribute your derivative over the addends, right? Get this. But the derivative of x1, derivative of 3, 0. So believe it or not, again, the derivative is just 1 here. Derivative of g, right? Times the function f. The function f as it is x minus 3. Over the function g, x plus 3 is squared, right? And the hint, the notice, do not work this out, leave it alone. The one that you have to work out is the numerator, right? The numerator. Y prime will be equal to what? 1 times x, 1 times 3, 3, right? Remember, multiplication by 1 basically does not change the factor, right? So here, similarly, but here is minus 1. So minus 1 times x, minus 1. Minus 1 times minus 3, minus and minus is plus 3 here, right? And over x plus 3 is squared, right? Very good. Now, therefore, y prime should be equal to what? X minus x, 0, right? X minus x, 0. Look, this guy and this guy, they cancel. But 3 positive plus 3 positive, 6, right? 6. So this one, 6 on the top. On the bottom, x plus 3 is squared, right? So looking through, then you can see that for number 7, the answer is here, right? Follow, guys? The answer is there. Yeah, let's finish this with this one. I'm gonna do it directly to show you that sometimes, even though the computations may look, you know, overwhelming, the algebraic computations, it's not that bad. You will see. Let's call this F. Let's call this G. Okay, we're gonna apply our quotient rule, which is F prime times G minus G prime times F all over G squared, right? G squared. So the derivative of our quotient should look like this. Derivative of the function on the top. Derivative of 5x, 5 comes out, derivative of x is 1, is just 5. Derivative of 8 is 0. So this is just 5 times the other guy, right? The other function, x squared minus 6x plus 4 minus the derivative of this guy now. The derivative of this guy is going to be 2x. Derivative of 6x is just minus 6. Derivative is 0, right? So twice x minus 6 within parentheses, right? Times the function f as it is, 5x minus 8, right? 5x minus 8. And on the denominator, we have the square of g, and we know that we don't have to expand this, right? We should leave this alone. What we have to work out is the numerator. It's a big thing here. Okay. And if the numbers, again, are not friendly, you may use your calculator to get this done. 5 times x squared, 5x squared. 5 times 6 negative minus 30x. 5 times 4, 20. Here you have to FOIL this out, but I recommend you use brackets here because there is a negative sign up front. So let's try to do it. I see someone already figured this out. Yeah, deep. Let me check. Yeah, 8. Deep. Excellent. Yeah, you got it. You figured it out. Excellent. Yeah, so we're headed there. 2x times 5x, 10x squared, right? 2x times negative 8 minus 16x. Negative 6 times 5x minus 30x. And negative 6 times negative 8, positive 48, right? Let me create the space here. Positive 48. The numbers got bigger, right? Big. So, but don't get discouraged again. You just continue working in order and the answer should come out. So y prime should be equal to what? Let's write this whole thing out. 5x squared minus 30x plus 20. Distribute negative sign over minus 10x squared minus and minus plus 16x minus and minus plus 30x minus and plus minus 48. The denominator, leave it alone, right? Leave it alone. Agreement, mathematical agreement. So just do this, y prime will be equal to whole thing. 5x squared minus 10x squared, negative 5x squared, right? Great. Now notice this guy, negative 30x, positive 30x, they cancel. 16x is left. 20 minus 48 minus 28, right? And that should be it. That's 4. All right, then looking through the choices, the one that is showing this should be, let's see, let's check. Which one is showing this? C, right? This one, right? Yep. Very good, excellent. As you can see, the denominator was left alone. The one that they work out was the numerator, right? Very good, very good. So carefully, you should get this done. Very good, very good. So with this, I think we should end this lecture. Yeah, great.